Hello everybody, my name is George Cryer, and I appreciate y'all being here, either voluntarily or involuntarily. So without further ado, let's get into my project. So my project I named Encrypticator, which stands for Encrypted Communicator. I just smashed those words together and hoped they sounded good, and they did. So my project is basically a encrypted communication platform where the server has very little knowledge of what is actually being stored on it. So that means that the only data the storage, or the only data the server holds is metadata. It doesn't hold any of the messages. Well, it does hold them, it just can't understand the messages. So getting into the preliminary part of my presentation, we got about me. I'm going to be majoring in computer science and computer engineering next year at Colorado State University. Go Rams. I am very proficient in Python, C#, and Java, and I'm learning C++ just because I enjoy that for fun. Not many people do, but I enjoy it. I'm also a fan of the outdoors and sleeping on the ground outside. A lot of people don't like that either. Anyways, getting into my logo. So I had a student here at Grandview High School design this with me. He goes by the name of Alex Nishida. Some other people in this room have probably used him for their logos. But I primarily use this logo and this logo just because I liked how sharp they were. I like the little fingerprint on this little fingerprint, which I see represents security, as well as the blue color, I think, in a lot of people's minds represents security. So moving on to my advisory committee. First of all, we get Steven Steinmetz, which is sitting right over there. He was my expert advisor at the initial part of the project. He really set my focus on what I should focus on, not to make my focus too broad, which I sort of did anyways. But he gave me a lot of good advice throughout my project. Then we have my support advisors, which were just emotional support. First, we got my peer, Prakash. He had his presentation yesterday. He really was just a bouncing board of ideas. I talked to him about my project, he talked to me about his, and all of that jazz. Then we have Gavin Housden. He just was there. We don't worry about that. And then we have my wonderful family members, or parents, Paul and Paula Cryer, and yes, that is their real names. But no, they were there for me 100%, even though I didn't utilize them that much. They always supported me. Now, my project inspiration. Primarily, I use Discord every day as a very big productivity booster. It boosts the productivity of my communication, and everybody I usually communicate with uses it. We also got Signal, which I rarely use, but I like the idea behind it. I know very little people that have used Signal in the past or even heard of Signal. And Signal is, let's think of it this way, it's a very refined encrypted messaging application that I don't know who uses it, I don't really care for the structure. I'm also a supporter of open source software. I personally believe that open source software is a better quality of software because it's community vetted and community maintained and overlooked. There's hundreds of thousands of contributors in the open source community, and I wanted to contribute. And I'm a very privacy-focused person, as my parents may know. I really do care about privacy in this world day and age with all those aggressive privacy policies on Facebook, Twitter, all these applications. I don't care for them. So I wanted to make my own implementation even though I didn't have the same resources as those bigger companies. So my project purpose, I wanted to complete work on a long-term project. Most of my dozens of past projects have been at max a month long. I haven't worked on them past that just due to motivational problems and the added complexity of them. I just get bored of them. And this project is one I've been wanting to work on for quite a while, so I thought it would be a perfect opportunity to work on a long-term project. I also wanted to learn and implement encryption technologies. In my past projects, when I thought about using it, I'm like, that's too hard. So this gave me an incredible opportunity to learn more about it and actually get diving into it. I wanted to get proficient with some industry DevOps practices such as version control. Version control is extremely important in the world of software development, and I just wanted to get as fluent as I could, even though I already had some minor experience in it before. I also wanted to become acquainted with large-scale software development. Between smaller and larger projects in software development, the smaller projects require much less planning, while the larger ones, initial design choices can set up the entire premise of your entire project. So that was something I really wanted to work on, that extra planning phase. And I wanted to provide an alternative, like I've said before, to some of these larger communication applications. So moving on to my timeline. That was me about a month ago. So my timeline progression, it's bad. So we initially got the planning phase, which is just research work. I did that for about a month. And then I moved on to structuring my application data structures and working on the server. Now, little did I realize I was going to work on the server for the rest of the year. I didn't get past that server point, and I never got to the client, unfortunately. But I put as much work as I did into the server. And just a brief overview, those are my 5 equal chunks, and it was completely turned upside down, like I said. Focused way too much on the server and skipped the client application portion. So some of my technologies used, this is just a brief list. So all of this project is written in pure Java. It's one of my favorite programming languages so far. So I really enjoyed using it. And then I also use IntelliJ's IDEA as my integrated development environment. That's where I built, ran, and tested all of my code, as well as MariaDB up here. It's a little hard to see, but I use that as my database. It's based off MySQL. I should have mentioned a lot of the stuff is going to go over a lot of people's heads, and I tried to simplify it as much as I could in this amount of time. So moving on from that, we got my project goals, which that's also extremely hard to read. So I wanted to implement zero-knowledge server encryption, or zero-knowledge server at the beginning of my project, which means the server knows nothing about what it's holding. But I was quickly realizing after the first month that with my technical ability and the time frame I was given, that would be very difficult for me to implement and very inefficient use of my time. So I opted instead to go for a server that has little knowledge about what's being stored. So what that means is that the server knows what metadata it's storing, such as identifiers, the time messages were sent, all of that jazz, but it wouldn't know what is actually inside of the messages, which was my main premise. So I also wanted to model a channel communication system, which is, think of a channel as a group chat in text. You have a list of people that send and receive messages, and everybody in that group chat can read them. Then I wanted to implement my own network transport protocol, which after like a week, I realized that was completely a waste of my time and out of scope. I honestly don't know why I thought that was a good idea initially, because there's plenty of already well-adapted protocols out there that I could have used, which I did use, that are very well tested, vetted by the community, and designed over many years. So that was out of the picture. Then we have my authentication and authorization code, which that basically, or that's a goal. I want good authentication and authorization for permissions and channels. So let's say you had an admin permission in the channel. That means you could modify things about the channel, delete messages, all of that. And then default users wouldn't be able to do any of that. And then I wanted, so most secure applications have a trade-off between convenience and security. That's true in a lot of applications. So if you have an application that's extremely convenient to use, it'll most likely be very inconvenient to use and non-intuitive. Or you could have, on the other side of the spectrum, an application that's very convenient to use, but not really secure at all. So I wanted to have a good balance between the convenience and security. Now, one thing that I wanted to add onto this is an asymmetric key exchange. So that means nothing to most of you right now, but I'll elaborate on it a bit later in this project. So moving on, we got what is encryption? Anybody? Go ahead.
Messing up the data so that it looks different and you don't know how to translate it.
That's basically right. I wrote the definition that it's the process of scrambling data so only authorized parties can understand it. So this diagram right here, it looks like you're putting the plain text hello into an encryption algorithm, and it's spitting out these random letters and numbers that nobody understands, not even the computers. So that's just a brief example of encryption. The encryption uses an algorithm, and as an algorithm, a synonym for that would be a cipher, which I'll be referring to the algorithm as both the cipher or the algorithm, of course. And then there's two types of encryption. There's symmetric encryption, which basically means it uses, and asymmetric encryption. So we got symmetric encryption, which uses one key to encrypt and decrypt all the data. So in this example down here, you can see that we're encrypting hello with the key, and then we get this random jumbled mess. And then we decrypt it with the same key, and we get the original text right here. So that's just an example of symmetric encryption. There's a very popular implementation out there called Caesar Cipher, which might help elaborate my point. Caesar Cipher basically works as a cipher. Well, it's a cipher. It's an algorithm. So if you input a key of any number from 0 to infinity, it will shift the alphabet for every letter in the input data by that number. So let's say I have the text hello, and I want to encrypt it by an offset of 3 or a key of 3. I would shift every letter in the alphabet by 3. So it would become some random jumbled mess. And if I wanted to decrypt that same data, I'd use the same key as 3, and I just shift the alphabet to the left, and I get the input message. So that's just a very popular and never used in computer security. I promise you that. Then we have asymmetric encryption. It's a bit different. It consists of 2 different keys, and the keys are both mathematically linked. So you have a private key usually and a public key. Now, if the public key encrypts, like it's shown down here, only the private key can decrypt. So the public key encrypts, gets that random mess of text, and then decrypts back to their initial message. And it goes vice versa as well. We have the private key encrypt and then the public key decrypt. That's just a brief example of what asymmetric encryption is. And usually a mix of both asymmetric and symmetric encryption are used to secure the internet. If anybody's familiar with TLS, that's how the basis of TLS handshakes work. I'm not going to get into that because that's a bit out of scope. Now, some project components. I have 3 major project components. We have the database manager, which connects to the database, which I said earlier, MariaDB, and that just stores all the data on the server. That's all that does. Now, it interfaces between the database, the actual database, and the rest of the application, or my code. Now we have the resource manager, which is a proxy, or in between the database manager and every other component in my application. Basically, the resource manager is just it makes the process of getting data a lot more efficient. I'll go into that in a bit. And then we also have the API controller. Now the API controller, it just is another interface or proxy between the clients and the rest of the application. Let's say all your phones are clients of the server, or they're using the messaging app. If they want information from the server, they contact the API controller and they get the data from the server. Now, the database manager, this is just some scary code that we're not going to go really into. But for the most part, this is just executing something called SQL. And it's grabbing the results from the database I need for specifically who is subscribed to each channel or who is a part of the channel. So it checks with the user and it gets every channel that that user is a part of. That's basically what that code is. That's a small part of the big database manager. We also have the resource manager, which I actually designed this to be multi-threaded, and so it would scale up to hundreds of thousands, if not millions of messages by initial design. I never got around to testing that, but that's how I designed it. This is just the initialization of the channels because it pulls everything from the database and it puts it into the memory of the application. So instead of milliseconds of response time from the database, we would get nanoseconds, which is a big performance boost, especially if I'm trying to sort through data. Now we also have API controller. On the top you can see this is just initializing all the routes or ways the client can communicate with the server. And on the bottom you can see this is how a client actually sends a message to the server. It sends a post message, which is just a slimmed down message, and it just implements it into the resource manager, and the resource manager implements it back into the database. Now this is probably going over a lot of heads, but we're just going to keep on going. If you have any questions, wait till the end. Universally unique identifiers. Now this is the backbone of my entire project. Without this, a lot of what I did would not be possible. And it's supposed to be a completely unique set of values, just to each object. So it's backbone, like I said before, and can be generated in a multitude of ways. My project follows the Twitter snowflake method, which a lot of other applications like Discord also uses an implementation of that snowflake. And so this is just a brief example of how it works. So we got the message or the identifier that's generated, and if you send that to binary, you're able to edit what is stored in that. So I use a process called Bitshifting to shove information into that binary, and then I could reevaluate it as a decimal. So specifically, I put a epoch, or a Unix epoch, which is every millisecond since January 1st, 1970, which is very specific, but we're not going to worry about that right now. And then on the rest of this is it doesn't relate to my project. I just found this is the best visual representation. But I also put a 6-digit integer, random integer, just to make the randomness a lot better, in case something's sent on the exact same millisecond. And I sent with it a 2-bit value that ranges from 0 to 3 of what type is the identifier referring to. So is it referring to a channel, an object, message, anything? Now, some of the project data structures we're going to get into. We got every object has a UUID. Everything. And we also have a message object, which is pretty self-explanatory. This is a messaging application. So every message object holds a message identifier, message contents, which are supposed to be encrypted, and the person who sent the message and the channel that sent it. And then we have the channel object, which stores a list of all the messages. And then we also have it store all the user objects, or who is subscribed to that channel, who is a part of that channel. Then we have the user object, and every message is referencing a user object. So getting into some of the code, we got this. This is a pretty self-explanatory object. I cleaned it up quite a bit. But like I said, message identifier, the sender identifier, channel identifier, and the contents of the message. And we have the channel object, which goes over a list. It has a list of messages and all the subscribed users. It has a creation epoch, like I said before, every millisecond since January 1st, 1970. And it has the channel name and channel identifier. And the user object, which has a bit more, it has a user identifier, a username, a hash password, which is supposed to be salted, which I'm not going to get into. We're going to have the date the user registered, the subscribed channels, what is that user subscribed to? And that's the basis for user. Now, some major pitfalls in my project. I drastically underestimated the size of this project. Usually, it would take dozens of software developers many years to do what I wanted to do, and I gave myself a year to do it. So that's, I guess I don't expect myself to get much farther than I already did. I think I made really good progress for how much time I had. And I also had initial design choices that really handicapped me. Some of those design choices, I focused my entire application during the first few months around MariaDB, or the database, like I said. And by doing that, I was unable to use a different database around December. I wanted to use something called Redis, which is an in-memory database. It would have replaced the resource manager, and I couldn't. Mainly because I made those poor design choices initially, and I was unable to use it without redesigning a large chunk of my project. And I just didn't have the time or the patience to deal with that. And then I spent too much time on the wrong parts of my project. I spent a lot of time on making the resource manager and the server in general extremely efficient. That was the majority of my time spent, and getting everything else worked on was not a priority in my head. And then I realized around a month ago, I don't have a client. So, and now, next step for this project, I need to complete the asymmetric key exchange, which I never really got into, but just for a summary, every client encrypts and decrypts messages, so the server doesn't. Now, the only way the client can encrypt and decrypt messages is if it has all the keys or encryption keys of other clients, and this would just give the other clients access to each other's public keys. And I can always go over this more on my table. And I wanted to implement the client side in the future. That's something I'll probably work on in a year after I'm back and ready to work on this project. And then I wanted to reevaluate the sorting algorithms I use to sort through the messages, because I think it could be even better. And I enjoyed that part of the project immensely. So we got a QR code here, which will be at the end of my bibliography as well. But here's my bibliography. Any questions? So the main thing about this was a learning experience, but yes, I would assume that other companies might implement this, or I'd start my own, but I didn't get that far. Any other?
How difficult would it be to implement the client side?
Honestly, compared to the server side, it would be drastically easier, because I have all the structures in place to implement the client side. I just need to do it. I need like another month to do it. Any other questions? Go ahead, Angela.
Since everything's relatively locally accessible, is there an increase in your system usage?
So I implemented something to be run on a separate server, like you specifically know with Plex, like on a machine in your basement. So this is designed to be on a different machine, and then you have like a client software like Discord or Firefox, and that would actually use the application. But this is just a link to it. Any other questions?
All right, thank you.